Hello everyone, I am Swapnil Kashyap. Then this is my ELL 101 project and my topic is detailed analysis on IC 741 OPAMP. So let's first have a basic introduction to OPAMPs. What is an OPAMP? An operational amplifier, also called as an OPAMP or OPAMP, is an integrated circuit primarily designed for performing analog computations. It has a very high voltage gain, typically of the order of 10 to the power 5 100 decibels. Although they are initially designed for performing mathematical operations like addition, subtraction, integration, differentiation, etc., hence the name operational amplifiers, by using external components like resistors and capacitors to create a required feedback mechanism. It can also be used as an amplifier and for many other functions like filters, comparators, etc. What is an IC741 op-amp? The IC741 op-amp is a monolithic integrated circuit comprising of a general purpose operational amplifier. It was first manufactured by Fairchild Semiconductors in the year 1963. The number 741 indicates that this operational amplifier IC has 7 functional pins, 4 pins capable of taking input and 1 output pin. So these are the different IC741 packages. Uh, okay, and this is the pinout diagram of IC741. They are numbered from 1 to 8. Their functions will be covered in the next slide. So these are its functions. So pin 4 and pin 7. Pin 7 is a positive voltage supply terminal and pin 4 is a negative voltage supply terminal. The 741 IC draws in power for its operation from these pins. The voltage between these two pins can be anywhere between 5 volts and 18 volts. Pin 6 output. This is the output pin of IC741. The voltage at this pin depends on the signals at the input pins and the feedback mechanism used. If the output is said to be high, it means that voltage at the output is equal to positive supply voltage. Similarly, if the output is said to be low, it means that voltage at the output is equal to the negative supply voltage. Pin 2 and pin 3 input. These are input pins for the IC. Pin 2 is the inverting input and pin 3 is the non-inverting input. If the voltage at pin 2 is greater than the voltage at pin 3, that is, the voltage at inverting input is higher, the output signal stays low. Similarly, if the voltage at pin 3 is greater than the voltage at pin 2, that is, the voltage at non-inverting input is high, the output goes high. Pin 1 and pin 5 offset null. Because of the high gain provided by 741 op-amp, even slight disturbances in voltages at the inverting and non-inverting inputs caused due to irregularities in manufacturing process or external disturbances can influence the output. To nullify this effect, an offset voltage can be applied at pin 1 and pin 5 and is usually done using a potentiometer. Pin 8. This pin is not connected to any circuit inside 741 IC. It's just a dummy lead used to fill the void space in standard 8-pin packages. So what coming to its specifications, so the it requires a power supply of 5 volts and can withstand up to 18 volts. Input impedance about 2 mega ohms. Output impedance 75 ohms. Voltage gain 2 lakh for low frequencies, 200 volts per millivolts. Maximum output current 20 milliampere. Recommended output load greater than 2 kilo ohm. Input offset ranges between 2 millivolts and 6 millivolts. Slew rate 0.5 volts per microsecond. What is slew rate? So it is the rate at which an op-amp can detect voltage changes. Now, a very important point is that the above mentioned specifications are generic and may vary from manufacturer to manufacturer. To get accurate information, please refer to the datasheet. So this is the internal schematic diagram of IC741. We can see many transistors, resistors, and here one capacitor also. So a standard 741 operational amplifier is made up of circuit containing 20 transistors and 11 resistors, one capacitor also. All of them are integrated into a monolithic chip. So coming back to it, let's understand the functioning of each transistor. So inverting and non-inverting inputs are connected to two NPN transistors Q1 and Q2 respectively. Both the transistors behave as NPN emitter followers with their outputs fed to a pair of PNP transistors Q3 and Q4, which are configured to function as common base amplifiers. This configuration isolates both the inputs and prevents possible signal feedback that might occur. Voltage swings at the inputs of op-amp can influence the current flow in the internal circuit, and it might go beyond the active operation range of any transistor in the circuit. In order to prevent that from happening, two current mirrors are used. Transistor pairs Q8, Q9 and Q12, Q13, Q12, Q13 are arranged to form the two current mirror circuits. The transistors Q8 and Q12 are the controlling transistors, which sets the emitter base voltage of the other transistor in the corresponding pair. This voltage is controlled precisely down to fractions of millivolts in order to allow only the required amount of current to flow. The first current mirror formed by Q8 and Q9 are coupled to the input circuit, and the second mirror formed by Q12 and Q13 are coupled to the output circuit. A third current mirror formed by the transistors Q10 and Q11 here uh, acts as a high impedance connection between the input circuit and negative of the power supply. It provides a reference voltage without loading the input circuit and sets the slight base bias current required by the PNP transistors at the input common base amplifier circuit. Transistor Q6 along with resistors 4.5 kilo ohm and 7.5 kilo ohm form a voltage level shifter circuit, which drops the voltage from input amplifier circuit by 1 volts before it is sent to the succeeding circuit. This is done to prevent signal distortions at the output amplifier stage. Transistors Q15, Q19 and Q22 Q15, Q22, Q19 are configured to work as a class A amplifier, and the transistors Q14, Q17 and Q20, these three, form the output stage of the 741 operational amplifier. To balance any irregularities at the input differential circuit, transistors Q5, Q6 and Q7, Q5, Q6 and Q7 are used to form an arrangement that takes in two inputs, offset null plus and offset null minus, that is the 1 and the 5, okay, and balances both the inverting and non-inverting inputs accordingly. So these are some very basic versions of the IC741. It can be used as an inverting amplifier and as a non-inverting amplifier. In this configuration, its gain is minus this resistance divided by this resistance, and in this the gain is 1 plus this resistance divided by this resistance. We can also see the waveforms. So coming to its applications, the first one is very genuine one, the amplifiers. So 741 IC is mostly used to amplify signals of varying frequencies ranging from DC to higher radio frequencies. It is also used in frequency selective amplifiers which filter out signals of unwanted frequencies. Example, tone control systems in stereo and hi-fi systems. This is computational one. Many electronic circuits that perform mathematical operations like integration, differentiation, summers, etc. use 741 op-amp. Next one is rectifiers. Ordinary diodes used in rectifiers have voltage drop across them, which makes it unsuitable for high accuracy signal rectifiers. The 741 IC can be configured to perform as an ideal diode, that is, with no voltage drop at all, and can be used in precise rectifier circuits. Next one is oscillators. OPAMP IC741 is used as an oscillator in function generators to create different output waveforms like sinusoidal, square, triangular, etc. It is also used in pulse width modulators. Next one is ADCs and DACs, that is analog to digital circuits and digital to analog circuits. So uh, 741 IP can be used to create DAC converters that can take digital binary input from computers or microcontrollers and create a corresponding analog signal. Similarly, it can also be used in ADC circuits. Concluding remarks. So in this project, We commenced with some basic concepts of OPAMPs, then looked at its specification. Then we dug deep into the internal circuit and saw the arrangement of transistors, resistors, and capacitors. At last, we get an idea about the applications of IC741 OPAMP and saw its tremendous scope in the manufacture of complex electronics. Thank you.